Hey everyone, today we are going to learn about Bohr models and be taking some notes over how to create a Bohr model for an element. So up until this point, we have discussed how the electrons are surrounding the nucleus of the atom. So they're not inside the nucleus, but they orbit around the nucleus. Well, they can actually be in specific places around that nucleus. And in order to show where those places are and where specifically those electrons are located, we draw what's called a Bohr model. And so today we're going to learn how to draw those, and we're going to write down some steps for how to draw them. So the first step that you're going to want to do is to draw the nucleus of the atom. And so I'm going to go down a little bit, maybe about halfway down my page, and I'm going to draw the nucleus of the atom so you can see what I'm talking about. This is just going to be a circle. So this is going to be our nucleus. And sometimes you might see people put in the number of protons or number of electrons in the nucleus. I'm just going to put the element symbol. So in this case, we're just going to do an example. Let's do neon. So I'm going to put the symbol for neon, which is Ne. So that's step one, just draw the nucleus. Step two, you are going to find the number of energy levels. Now, energy levels are what the electrons sit on. So I want you to think about the solar system. Think about the sun as your nucleus. And then we have planets that orbit around our sun. Our electrons orbit around the nucleus, much like the planets do. And how the planets are spaced out at different distances, our electrons are also going to be spaced out at different distances. Those are what we call the energy levels. You might also hear people say them as energy orbitals. So we have to find that number of energy levels first. And how we do that is by using the periodic table. And you are going to look at the period number on the periodic table. So remember, your periods are going down the side of the periodic table. So we have period 1, period 2, period 3, all the way down to 7. So if we are looking at neon, if we see, is in period 2. So we know that it has 2 energy levels. So I'm going to write that down here so we don't forget it. So it has 2 energy levels, or orbitals. And so our step number 3 is then to draw those energy levels. Now, what those look like are just like rings around the nucleus. So let's draw the first one. Here's 1. Draw the second one. There's 2. So there's our second energy level. Now, our fourth step is to find the total number of electrons. So find total number of electrons. Now remember, to find the electrons, we are going to look at the atomic number. So on the periodic table, if we're looking at neon, neon's atomic number is 10. That means it has 10 total electrons. So I'm going to write that over here. So 10 electrons. And then our next step, step number 5, is to place those electrons in the energy levels. So we do have a couple of rules when we're placing them in these energy levels or these orbitals. We can't just place them wherever we want. So the first energy level, so that's going to be this first ring, okay, outside the nucleus. That first ring out there can only hold 2 electrons. It can only hold 2. The second energy level So that's going to be this ring right here. That one can only hold 8 electrons. And then sometimes you might have a third energy level. If we had a third energy level, that would hold also 8 electrons. So now that we have our rules, we can place the electrons in this Bohr model. So we know we have 10 electrons total. So I'm going to start with placing 2 in the first energy level. So the first one can only hold 2. So I'm going to put 2 in the first. So 1, 2. Now I have 8 more to place. So I placed 2. 10 minus 2 is 8. I have 8 more to place. I'm going to place those 8 in the second energy level because the second one can hold all 8. So draw them around here. 2, 3, 4, 5, 6, 7, 8. So again, make sure you're counting. If we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we've reached our 10 total. And now there is a way to check to see if what we did was correct, and that's by counting what's called valence electrons. And this is something you are going to need to know what it is, so I'm going to write the definition up here. Valence electrons are the electrons that are on the outermost energy level. So what you can see right here, this one for neon has 2 energy levels. Your valence electrons are the ones that are on the outside. So if we count, we have 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. Now, let's say you didn't have a Bohr model and you only had a periodic table and a question is asking you how many valence electrons do you have for an atom. What you can do is you can take the group number minus 10 and that will give you the valence electrons. So let's look at neon and see if it works. So neon, we know, is in group 18. So remember, groups go across the top of the periodic table. So neon is in group 18. So we can take 18 minus 10. That gives us 8. If we look down here and check, 1, 2, 3, 4, 5, 6, 7, 8. We know that we have 8 valence electrons and we have drawn our Bohr model correctly. Now I'm going to place this equation up here too, so you can write this in your notes. So how to find your valence electrons? You're going to take your group number minus 10. That way you have that in your notes as well. So now let's do another example so that you can also try this. So we've just done neon. Let's do sulfur. So first off, what we want to do is we can follow our steps, and then this one kind of has some things drawn out and written out, so we're going to fill those as we go along too. So the first step is to draw the nucleus. Well, that's already done for us. Okay, so this is our nucleus right here. Now let's say we are just going to put in the symbol. So sulfur's chemical symbol is S, so we're going to use S for that. Now number 2 is to find the number of energy levels, and again we're going to look at the period number to do that. So let's look at the periodic table. On our periodic table, sulfur, if we go all the way across, is in period 3, so we know that we have 3 energy levels. Let's go down to number 3. It's going to draw the energy levels. Well, we have 3 energy levels all drawn out for us, so that's already done. Let's move down to number 4. We need to find the total number of electrons looking at the atomic number. So let's bring the periodic table back out. Find sulfur. Our atomic number is 16. So we're going to write that down for atomic number. That's also the number of protons and the number of electrons. That's what we were trying to find for step number 4. Step number 5 is to place those electrons in the energy levels. Now, please remember to follow those rules. So we need to place 16 electrons. So following these rules, I'm going to put 2 electrons in the first energy level. I'm going to put 8 electrons in the second energy level. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we still have 6 more to place. Those are going to go in the third. So I have 1, 2, 3, 4, 5, 6. I always count at the end to make sure that I have the correct total number of 16. So count to make sure that you have the correct total of 16. Now, in order to check ourselves, let's check to make sure that we have the correct number of valence electrons on the outside. So let's go back to our periodic table. Remember, you're going to find the number of valence electrons by taking the group number minus 10. So if we look, here's sulfur. Sulfur is in group 16. So you take 16 minus 10, that gives you 6. So here we should have 6 electrons on the outermost shell. So let's count. 1, 2, 3, 4, 5, 6. Yep, we have 6 electrons on the outer shell. That Bohr model is complete and correct. If you have questions about this, please email your teacher and we'll be happy to help.